Welcome to EdmontonPy, the Edmonton Python user group. EdmontonPy.com on the website if you're looking for it on the internet, EdmontonPy on Twitter. We also hang out on the Dev Edmonton Slack on the Meetup Edmonton Py channel. So if you want to connect with anybody outside of, the day today, just on a regular daily basis, lots of us are on there and hanging out. Say hello. Today's meetup is sponsored by Drivewise. Yifeng here is going to just give us a little, 30 seconds rundown about Drivewise company, because this is the first time they've sponsored a meetup, so we're super thankful.
Thank you, Ashia. My name is Yifeng, and I'm from Drivewise. I'm a DevOps engineer. At Drivewise, first of all, Drivewise, we are a software company. We have a lot of different products, but mainly highway bypass services for trucks all over North America. We're the number one in the market, and our competitor is using technologies back in the days. And we're also the only company, as I was told, the only software company that got investment in the last year. So we're growing. At Drivewise is really fun. We want people who keep it real. Like, we want people who doesn't really, just get a job done, right? And also we have a lot of extra activities too. Like, people really enjoy working here. We play games, we play soccer, we have karaoke night sometimes. I had one time. It's a nice place to work, and we sponsor pizza.
I assume with that speech of yours that you are hiring Python developers?
We're always looking. The thing, we always have that thing on our website is send us your resume. Right? Look at you as a person, find out if it's a good thing. We're always looking for good people.
Awesome. We appreciate the community engagement. We're also sponsored by Startup Edmonton, which is the space you're at here. We're super grateful that we can always meet up in this room and not have to, go around the city and try to find space at the last minute. So it's just amazing to have this space. We try to abide by the Pac-Man rule here during our chat sessions. So when you're standing in a group of people, just leave a little bit of room for someone else to enter your conversation, and that makes it so much easier for people who've never been here before to just get to know other people, not just be really welcome and inclusive to everybody else. So Pac-Man rule is a thing. If you know of any other jobs or any companies that are hiring, definitely speak up. And if we try to post opportunities on the opportunities channel at Dev Edmonton Slack, that's a really great place to look for as well. We also just wanted to plug in the Polyglot Conference, which is a conference for software developers here in the city. It's called Polyglot because it's not tied to a specific tech language, so it's not just Python. It's kind of across all of the tech stacks. So it's probably one of the largest, there's about 90 software developers this year. They're gonna, and software developers, anybody else related to software development in general, that's gonna come together on April 4th. And get together and do panels and talks, and it's kind of like an unconference, so it's very, I can't tell you what we talked about because the decision what's going to be talked about is actually going to be decided the day of, where people are kind of voting on topics and things like that. It was really, really great last year, and this is a second iteration. So if you can make it out, that's a great place to kind of meet other software developers and companies across the city. So that'll be on April 4th. The other event that's going on, if a little bit risky, of course, traveling to a conference, but PyCon US as of yet is still happening, and it's in Pittsburgh on April 15th to 23rd. We just kind of have to keep an eye on whether they're going to cancel or the conferences or not. Pittsburgh as of yet has a very low number of cases, so I think they're still trying to see if it's going to be a success, but it is as of yet still going on. So if you're into that, definitely come check it out. PyCon US is a great event. Some news, the newest Python version, 3.8.3, Django got released 3.05. There's a security update, so definitely take a look at that, particularly if you're running Oracle. The latest Talk Python episode was a chat about the Python mentorship, about a couple of folks that kind of were self-learn and got to learn Python and got to get into the career as a software developer through self-learning, through mentorship, not necessarily through kind of the more traditional channels. So it's a great episode. Podcast in It did a chat about advanced Python task scheduling, so kind of similar to Celery. And Test and Code did last episode on amazing PyTest planning. PyTest is an amazing testing package in Python, much more Pythonic, I think, than some of the other test cases, and a lot of people have been really happy with the direction it's going. So it's got a lot of great plugins. Yes, Dan?
There's also a really great Django podcast called Django Chat that did a really similar for Python mentorship for resources and mentorship, and that was released on Wednesday.
Nice. That's a great one, too, to add to the mix. A couple of articles that I'll just kind of mention that we've seen. I'll show these slides on the Meetup channel on the Edmonton Slack, but some things that stood out for the last couple of weeks was there's a really great article about Python requests, and I think a lot of us are pretty familiar generally with the request one, but maybe not as familiar with some of the extra features that it has, including things about timeouts, retrying, and doing particular hooks when certain status is encountered to kind of automatically go into that. So that's an article that you can check out. If you're just getting into Python, if you're just learning Python, the next kind of three are in that you'll be interested in. Well, the first one is just everything you need to know about dictionaries. So creating dictionaries, updating dictionaries, all the way up to dictionary comprehensions in Python. The other one is exception handling, common pitfalls of Python exceptions. So it's kind of like how to write your exceptions and what are the best practices when raising exceptions, re-raising exceptions, and so on. Python mocking 101, fake it before you make it. Everything you need to know about mocking when you're doing tests. Mocking for me was just conceptually difficult to understand. And so any article that has on mocking, I'm always just like, I need to go back and read this, because sometimes the pathing to understand how to mock the proper thing takes a little bit of knowledge. So that one's really great. There was this YouTube video of someone doing a game jam, and they took 48-hour game jam and they made this game with Python and Pygame. And it's just like a 3-minute video, but it's pretty amazing to watch 48 hours in 3 minutes and seeing all the little chunks that kind of go into making a game. So that's really neat to watch. Another article that was really great was the data cleaning in Python, the ultimate guide. So that was a very recent article written in 2020. And it talks about things like missing data, data irregularities, data duplicates, and how to deal with some of those issues. So probably super relevant to anybody who's dealing with data on the data science side. And then managing Kindle highlights with Python and a GitHub. This one is particularly neat because sometimes we want to use Python just like a little tiny project for yourself that isn't necessarily complicated, but it's super useful to you because it's something you're automating. And this article just, it's one class, it's 2 classes book and kind of highlights, and then a tiny script to actually pull those things together off the Kindle. And I just think it's a really great way to kind of, good example of the types of Python small projects that you can work on when you're learning Python. So hopefully those will look useful. I will post these on the Edmonton Meetup Pi channel, so you can kind of see all the links, and these are also on slides.com/EdmontonPy if you want to look at them more directly. A little Python tip, try and excepts have things other than try and except. You can also do an else and a finally, and sometimes you forget that, so I wanted to kind of highlight that the else will run when the exception doesn't occur, and the finally will always run whether you had an exception and an else. And so definitely include those in the mix. Keep in mind when you are doing the else, which, when your first exception didn't occur and you want to do something else, that you should probably make something simple, something that wouldn't catch another exception, because then you don't have to nest them together, and that would make your code a little bit less readable. But if it's something small that you're dealing with, then the else is really useful. Today's talks is Intro to Pandas by Analyzing Shots in Hockey by Mr. Dan Morris here, which, coincidentally is being done when there's a hockey game, so good timing. And Sam is going to do a talk on Python Decorators, a primer on that. So that's what we'll look forward to today. We'll have a break in between the talks. We'll have some pizza, we'll do some chatting around, and then we'll do the second talk. As of yet, we don't have a date for the Python Meetup next month because it actually lands on Easter Monday. So we'll typically try to see if we can get a Tuesday on the next day. So we'll share the news when we know what Startup Edmonton is like, yes or no, or this day is this day. So as of yet, it'll happen. We just don't know what date. And if anybody wants to do some talks over the next couple months, come see me, come see Dan, come see Aaron. I will convince you, even if you think you have nothing to say, I will still convince you to come and do a chat. You can learn a lot just by speaking. Dan, it's all you.
Okay, great. Howdy, everybody. I'm Dan. For those of you who don't know me, I help organize with a couple of us. So today what I'm going to be talking about is a lot about hockey. So who here is a hockey fan? A few of us? That's totally fine. So I'm going to be talking a little bit about shot analysis. So myself, I'm pretty disgruntled just because the Oilers don't make the playoffs. Hopefully they will this year. But so this has kind of like led me to kind of analyze a little bit of shot data to see what is a high danger scoring chance. There's a lot of, when people kind of like broadcast, they talk about high danger scoring chances, and that's what I'm going to be talking about today, just kind of analyzing what are kind of like the differences of where you shoot, and we're going to be kind of doing that. So to be able to kind of get there, to be able to see all the analysis, there's some parts that I haven't built in yet, but what I'm going to be talking about is setting up a notebook and our data. As well as a note before I kind of go on, if you want the, everything's on the Slack, so if you do join the Slack, you can get to this repo to be able to do it. Okay, so the first thing that we're going to do, we're going to set up our notebook with our data. Then we're going to be filtering out some data with Loc. Then I'm going to be kind of visualizing a little bit of our data to see what the heck we have, how we've done it. Okay. Then I'm going to go through this really long calculation that we're just going to kind of gloss over. That's going to be how do we calculate if it's in a certain area where those shots are, which I call the home plate area. And we're going to see exactly what the home plate area is. We're going to create a new column with apply, which is a function on a data frame. So we're going to be creating a new column, which is whether or not we can, it is in the home plate area. And then we're going to group our data together to get some percentages. Okay. For those of you who want to follow along or will run this, this is really meant for introduction. So I just got a picture what this actually looks like. So here, if I go down, this is actually my notebook running locally. And this is what it looks like. So you're going to need a Python installation, virtualenv, pipenv. That's actually discussed in the README. Okay. But let's talk about setting up our notebook, okay? So the first thing here that we're gonna do is actually import pandas. This is pretty common to do as just kind of like saying it as PD, which is basically just gonna be an alias to be able to use pandas rather than writing pandas every time, okay? I've got my data set in there. I actually have it included in the repo. If you wanna go take a look at the data, I do have a link to it. It's basically from kaggle.com. If you haven't taken a look at that, it's a pretty good website. And I've got the NHL data, and I'm loading in via a CSV here in the in3 section that I've got highlighted that I'm going to actually read in all the gameplays from 2010 up to 2018, 2019. So we can confirm that we've got a data frame just by checking type. You can do this with a whole bunch of classes as well, just to see what kind of class it is. So we've gotten a whole bunch of stuff, but let's actually take a look at the first 30 rows, okay, of our data. You can do this with head, okay? So I've got a bunch of plays here, and as you can see, there's a whole bunch of events. like giveaways, which the Oilers have done a ton of in the last 13 years. Blocked shot, which is like what Oscar Klefbom mostly does. We have a couple of events that are going to be of interest to us. The type of event is one shot, and the second one, if I can find one in here, it's a goal. Okay. You also have the types of shot that it is, which is really great. So we are going to take a look at that a little bit later on as well. One thing that is pretty cool about our data as well is that it actually gives us the X and Y, basically where it is on the ice, to be able to see where our kind of shots are being taken. And we're going to see, kind of do a little bit of a hex bin there to be able to see kind of a little bit of density of where it is. Okay. As well as X and Y, there's standard X and Y. It's all standardized so that when you're shooting, because in hockey, you change ends at the second and third period between periods. So you shoot one end, then you shoot the other end, then you shoot the other end. So standard X and standard Y, that's a lot of what I'm going to be dealing with today, is all shooting towards one side. Okay. And as well, I do have a couple of notes there. For you if you want to follow along later on and just kind of dabble. Okay, so if you were wondering, head only gives us the first 30 rows, but how large is it actually? You can actually get the shape of a data frame where it's going to be rows, comma, columns. And here we see that we're going to be analyzing or filtering out 3.6 million events. And yeah, so we're going to have quite a bit to be able to, quite a large data set to see where shots are normally taken throughout a game. Okay. Another thing that's really fantastic from Pandas is that you can get the data types. So Pandas has their own data types that they've created that are really optimized. So here you can just write DF gameplays, which is my data frame, and I'm putting in the data types in there. So it's going to give us, so here, some of the stuff that we did talk about, the event, X, Y, standard X, standard Y, which is pretty nice. Okay. So the next thing that we want to do is that we've got 3.6 million events. We want to see basically the things that we actually care about, okay? So I've got a couple of extra commented out lines of code, but I'm just going to discuss of this one. Loc allows us to basically filter out based on some certain condition, okay? And the two conditions were here. You're going to see there's two arguments. One of them is the Boolean to basically match the strings in the event. So here I'm saying in a DF gameplays on the event column, I want to use string to match shot or goal to be able to just get those points. Okay. As well as the second argument there, I've filtered out just the columns that we care about. And that's going to be the event X, Y, standard X, standard Y. Okay. And you can see here on the output that we have the event type, we have the X and Y, and you can see that, are any of them flipped? None of them are flipped for this one, but it does flip for second period shots. Okay. And that's kind of like a quick primer to basically just filtering out those shots. Okay. So what I want to do here is I actually want to visualize what I've done. Okay. So I've got a, I'm going to import matplotlib, and I was trying to add Seaborn to some of the graphs. Some of them are a little bit more complicated, and I haven't added them in because I was rushing to finish this right before So my apologies on that. And as well, I'm going to execute matplotlib in inline so that it's going to basically display the plots right there. Seaborn uses matplotlib, so whenever you're going to see SNS, when I call it in the code, this is actually Seaborn. Okay. So the next step that I've done is I've kind of like added the actual kind of like preferred shot locations, and I've just done a couple of things here with standard X. You can add a couple of things here to see some more conditions. Basically, what am I doing with standard X greater than 0? I'm basically assuming that if you're taking a shot behind your own red line, which is like 100 feet out from your kind of like from your or the goal that you're shooting on, I'm not really going to count that as a meaningful shot or a meaningful chance, because that takes way too long, and I think I've only seen a couple of goals scored from past the red line, and it's big news when it is. Okay, so here, what I've done is I've actually just made my matching condition as just a clause that I'm just going to add in using loc again. Okay, and as you can see, still has the same shape because I didn't add in the second parameter there. This is basically saying, hey, include all of the columns in there. Okay. So the next thing that I want to do is I'm just going to create a scatter plot with all of the shots in there. So we can see a little bit of the shape of a rink. There's a couple of weird ones that I didn't kind of like remove. As you can see at the bottom there, the bottom right side of the right by 100, that looks like they're taking a shot from the stands, which is kind of weird, but we're going to include it in for now. But this would be something to consider later on to actually remove some of the pieces around the curvature of the boards. And you can kind of see a little bit of the curvature of the boards at the top right of the graph and the bottom right of the graph. Okay, so this is basically the net is 0 and about 90. Okay, so you kind of see a dead spot right there, and that's going to be where you have. I also have just using matplotlib if you want to run those, if you want to kind of take a look at that. Okay, so the next shot, or the next kind of like piece, is I want to have a little bit of a analysis about where are shots normally taken. Okay, so you can see here, right around the net, you can see that people are banging pucks in all the time, because that's going to be where a lot of your rebounds and a lot of kind of secondary chances come in. But you can also see a couple of weird spots where shots are a little bit more defined on the outside there than kind of right above the ringette line, or right above kind of the circles near the center. So that's actually kind of something interesting that I've seen from this data. Okay, yeah. So this is just a hex plot to be able to show a little bit more of density. The KDE plots were taking way too long to render, so my apologies on that. I will have that. So again, this is following that same rink. So it's got that on the side, and the net is right about here. Okay. So I've got the ST max, max and min just to basically show the edges of the graph. So this is basically just showing us that half the rink is about 100 feet, and it's about 42 feet from the middle, both sides. So just to kind of show a little bit more of that. Okay, so what do we have right now? We have a little bit more of a distribution of shots, and we can see this scatter plot, which is basically useless to us, but just the fact that it is kind of taking the shape, and since we're taking shots from 2010 to 2019, the end of 2019, this should be littered with all the spots, right? To be able to show that. But why am I actually giving this talk? I want to see high danger shots. I want to see when Gene Principe stopped making a weird pun when you're watching the Oilers. I want to see if this actually makes a large difference. So we're going to see kind of those parts and see a little bit more of the shooting percentages, so how many shots go, or how many shots turn into goals from this area versus the other kind of like spots, okay? So this is a little bit like our graph, okay? So you see here that we've got the one side of the rink, okay? And a high danger scoring chance, this is kind of like a home plate. If you've played baseball or you've been to a park, it's pretty similar to that, except you're just saying basically from the bottom of the nets out to the dots, up to the top of the circle. These are what's considered high danger scoring chance from a lot of the people that are in hockey around there. They always talk about the home plate, and I wanted to prove it. So this is what we're going to be actually taking out from the graph. Okay, there's a couple of things here for rink dimensions, and I've talked a little bit about my calculations, which basically, I know that I probably could have done this a little bit cleaner, but I have a rectangle here, a rectangle in the middle, and 2 triangles on the side. And I know that you're probably thinking like, hey, you probably could have done one big square and removed the 2 triangles. I'm not a rocket surgeon, so that's probably should have done it that way. Okay, so what I'm going to do here is I have a couple of, I have a lot of calculations here, but basically the whole gist of it is I'm checking to see if it's in the triangle, if it's within these points to be able to see it, to be able to see if it's in the home plate area. So if it is in the home plate, you can trust me on this. We're going to see a plot that actually shows if it is or it isn't. Okay, so we're just calculating to see, again, if it's in there. Okay, so how am I going to do that? Okay, so we are going to do that by creating a new column in our data set. Okay, so what I'm going to do here is I'm going to create a new column here in our data set called is in home plate. Okay, I'm also going to pass in our preferred shot conditions, which were from before, saying, hey, I only really care about the shots that are past the red line. Okay, and what I'm going to do here is I've got, as a first parameter, I just have a lambda where I'm just passing either true or false from the home plate as a result, and I'm passing in row. I'm saying I want it to be on the row and not the column, okay? So I'm going to be applying this on each row as we kind of go forward, okay? So when now I take a look at my loked, so a little bit filtered with my preferred shot conditions and the columns, which we have seen from before at the beginning, okay? I'm just seeing the head here. So here I can even get the description. So I know that there's not too many hockey fans here, but easy breezy, we can see that he made a save within the home plate, and here are the actual points where you can actually see where the shot is being taken right now. So that's going to be pretty close to the net and just a little bit off center, okay? So, but we can actually see our scatter plot and see if we've implemented this correctly. And as you can see here, I've got a pretty similar plot here to what we have seen from the demo. I've just said, hey, I want to see all the shots that aren't in the home plate, okay? So I've added that in our preferred shot conditions, and I still have the same conditions from before, but I'm making this in a variable just so that it's a little bit easier rather than kind of putting all the stuff in there. Okay, so here, DF game plays, shot conditions. I could make this into a data frame. I thought about that too late, but that's fine. Okay, so here for the X side, and this is using Seaborn. Okay, so the X is the standard X on that side, and the Y is just again the width of the rink. Okay. As well, one thing that's pretty interesting is since we saw at the beginning our hex plot that kind of shows us a little bit more of the densities of where shots are taken, we can see here that the shots are actually a lot more condensed. This is kind of right inside the blue line here. And again, there's a couple people still jamming it in on the side of the net, which kind of shows us a little bit more and gives us some more insights of where people are actually taking shots and some patterns in how the game's being played, which is pretty interesting. But to be able to quantify a high danger chance, I want to see how many shots actually go in. Okay. So what I'm going to do here is I'm going to group by the events. Okay, so again, the preferred shot conditions, just the same. I've just reset it so that it's not necessarily in the home plate. I've said, hey, I want to group this by the event. I want to get the value counts from whether or not it is in the home plate or not. And as well, then what we can see is a graph that kind of gives us a little bit of insights. We can see that if it is in the home plate, this chart is a little bit weird, but the goals are a little bit higher than actually if they're outside. And you can see one thing that's actually pretty interesting is that it's relatively even whether or not shots are being taken within that home plate area, which is really close to the net, versus outside, which is really interesting. Okay, to take a look at the values once I actually have ungrouped them, okay, I could use unstack just because there was multiple keys there. So what do I have here? I have whether or not it's in the home plate and whether or not it's a goal or a shot here. As rows. So what I want to do here, and I find that will be a better graph, is transposing it. So making it so that the goal and shot are not rows, but they are columns. And whether it's in the home plate are the actual rows. Okay. So what we can see here is that though there are more, and this is just from like kind of taking a really quick view at it. I'm just plotting it with matplotlib. For some reason, I'm struggling with creating stacked bar plots in Seaborn. I will return back with better plots soon. But I've got it so that I've unstacked the values, I've transposed it, which is what we have here. So now we get, is it in the home plate? Yes or no? And we actually see the stacked values, whether or not it's a goal, which is blue here, and a shot, which is an orange. So this is kind of like our original inkling, hey, high danger scoring chances aren't bullcrap. They're actually, they actually make sense. So, which is probably what we expect. So what I want to do is I want to get the actual shooting percentage. So how many shots go in, okay? So what do I have here? I've got the test home plate data, which is our transposed values. I got the head to be able to show what I'm doing. And what I'm going to do here is I'm going to make a new column called shooting percentage. And that's going to calculate the goals, okay, divided by the shots and goals, which is our shooting percentage, right? Because a goal is still a shot. It's just a shot that goes in, which, as an Oilers fan, you've probably seen a ton of. So here we see our shooting percentage, and we can actually see already that if it's not in the home plate, this is something that actually astounded me, is that the average or the shooting percentage of all shots from then is 4.4%. And if you're just smashing it in that home plate area, you actually have 15%. That's 11% difference of where you take your shot of how probable it's going to go in. Again, this is not taking into account stuff like rebounds, but that's a significant difference. And again, just to kind of plot it, you can see if it is in the home plate area, it's 3 times as likely to go in, which is actually something I wasn't expecting. So as well, what we can do for fun is we can actually take a look at the different types of shots. So there was a column in our data called secondary event, which you can kind of take a look at a little bit earlier, that's going to talk about the different types of shots. And you can see which shots are most effective. So blue here means that it is a shot outside of the home plate area, and red means that it is. So you could see something that is pretty interesting. Who here has played NHL 95 before? No? Tough crowd, tough crowd.
I think they may be at the hockey game.
Yeah, so in the NHL 95, you always used to be able to score on wraparounds, but you can see here that they've got less than a 5% chance of going in. But one thing that you can see, yes?
What's a wraparound?
A wraparound is like when you go around the net and you try to jam it in when you go all the way around the net. Thank you for clarifying that.
Is that like a super sneaky strategy?
Yeah, it's a super sneaky strategy. So you don't shoot originally, you kind of skate around the net and you try to like jam it in. So it works very seldomly, but in that video game, it worked a ton and it was really awesome. So yeah, so that's something. But one thing that is very interesting is deflected shots and tip-ins seem to have the lowest discrepancy of them. So a deflected shot just means that someone shot the puck and they deflected with their stick. So you could see that actually has right here, they're really likely to go in because of the misdirection with the puck. And tip-ins, that's kind of when it's on the ice and someone passes you the puck and you just kind of tip it in. That's actually really interesting that those are the two shots that have the highest basically shooting percentage combined between both of them, which is really, really interesting. Some more stuff I didn't know, right? As well, I've got all of the shooting percentages here, just all kind of a little bit more defined in a table. So the secondary type, so what kind of shot it was, whether or not it was in the home plate, and you can actually see the numbers here of goals and shots, and then each one of their shooting percentage, which is actually quite nice. Okay, so yeah, that's basically it for a intro to Pandas. This is kind of using some of the more basic features of Pandas. There's a whole bunch of other features that either I found were going to be too difficult to cover or to try to keep it short. And as you can tell, I'm kind of a chatter. So we kind of have that. So I've already used my NHL 95 lied to us joke. So that's kind of something, there you go, that totally fell flat on its face, but whatever. And yeah, so one thing that is kind of there that I have learned from doing this is that shots are much more effective from that home plate area. So when you hear a broadcaster, maybe you'll tune in when the Oilers hopefully make the playoffs in 35 years. But that's one of the things that's actually quite interesting is that they're actually, if you take the shots from that area, it's a lot more effective. Okay. So I do have a couple of ideas. I'm probably going to be updating this repo a little bit more with hopefully some models in the future because I want to beat a coin flip, and that's kind of it. But besides that, that's kind of my talk.
All right, we'll open it up for questions now.
Yeah, because there's way too many hockey fans, so.
Well, just before questions, I just want to let you know it is actually 1-0 for the Oilers right now. So
Who scored?
who scored? Jason, of all people.
Oh, holy Jason. Oh, jeez.
There you go. All right, questions.
Yeah. Yes.
Are deflections the same thing as rebound?
No. So this is something that I've been quite interested in. If you are interested in this, there's a guy whose name, he does a site called Money Puck, and he actually kind of talks about a lot of how how rebounds work. So basically, those are shots that happen within a couple seconds of the previous shot. And he actually measures the angle from which is the angle of the previous shot versus the current shot. And he says that like the higher the angle, the more likely that it is to go in, which is kind of funny, or not funny, but it's pretty interesting because if you shoot the puck off his pad, the goalie's pad, like low, and someone else, say for example, not Tobias Reeder, hopefully someone gets that joke. If you have, for example, Alex Chason on the wing, he would just be able to bang it in. And he's got a much higher percentage. So this doesn't take into account rebounds, but that's something that I definitely want to take a look at in the future. I think you were first.
Do you think that there would be, depending on the opposing team's defense, if they could force you to take more of your shots from outside the home base, and would that impact like how we're doing against those teams?
That's something that I think that I can kind of, I'm thinking about of how to kind of make this and improve this. Getting coaches and how long that they've been with teams, I think that we could get a little bit of that data because say for example, if you're Dallas Eakins, you basically just let people walk in. But if you're Dave Tippett or you're a Barry Trotz as a head coach, you actually just really force your teams to block a ton of shots. And you can actually see that from the NHL website. They track blocked shots, and Barry Trotz, who won with the Washington Capitals, he coaches the Islanders right now, which is very important. It's not important. He forces his team to block a lot of shots, so that's going to force it. There's a measurement called Corsi, and Corsi is all shots directed towards the net. I've only included shots that have hit the net, not missed and blocked. So that would be something to improve this. So yes, you could. And as well, you could measure the percentage of shots that get through, which is because you get the blocked shot event as well, which is pretty cool. Yes?
Have you considered posing your data in a different format? You've got X, Y, and there's also a kind of symmetry to it. You could kind of pose it as angle and distance.
Yes, that's something that, again, I'm going to give a job to Future Dan, because that is a lot of, I mean, if you're kind of straight on to the goalie, you have better chances to score because you have more net to shoot at, unless you're Tobias Reeder, of course, because he scored 0 goals last season for the Oilers. So, not that I'm rattled about that, but yes, that would be something that I really want to take a look at a little bit more. So the angle towards the net, which, you know, our math days, gotta do that. So, yes. Yes.
Just throwing ideas at graphs I'd like to see, or just a heat graph on the whole word.
Yeah, so that was actually something that I was trying to rush to get done, but some transposition, I was just doing it like crap. So next time, if I do talk about the model, if I can beat a coin flip, which is more difficult than it sounds, I will definitely have the heat map of like where shots are being taken so that it actually kind of like shows. I had the KDE plot that kind of like had it so that it kind of had it, but I ran it and it was just taking forever. And I had to get here. So it was either KDE plot or get here. So yeah, no, that's awesome. Thanks for the suggestion. Yes?
I'm curious, when you approach this kind of problem, do you approach it from like you already know the solution, like you know what you want to do, or do you like start with the data and then like explore it step by step as you're kind of getting to see it one graph at a time?
I try to graph quite a bit. The exploration of the data, the kind of like seeing the unique values and being able to analyze, because as well, I want to take a look at events quite a bit, because passing data is not around yet, but that's going to be something that hopefully is going to be coming to the NHL. I kind of just like poke around and see that, but I know that there's going to be more of this, and now that I kind of really understand this piece of the data set, I want to go and explore more of it to create models so that I can hopefully get hired by an NHL team that doesn't lose all the time. Just kidding.
May I
Yes.
assume that you learned a lot about pandas?
Yeah.
A talk on pandas?
Yeah, this was great. This is, yeah, I absolutely learned a ton about pandas. I've dabbled with it a little bit before, but with this and a couple of other projects and kind of moving forward, I know that this is something that I am quite interested in. And hopefully, I can kind of glean.
Strategically ask that question to illustrate that if you would like to learn something specific, that giving a talk at the meetup is a really great way to kind of go more.
Yeah.
Learn that.
As well, it's kind of like learning with a deadline, right? So if you want to kind of do that, I highly suggest it. It's a really good time, and normally people really like this. Yes?
I was just going to say, this is very interesting because there's some of what you're saying. I mean, I watch hockey. I'm a hockey fan. I still play hockey. And so the piece about the diamond isn't a surprise. What is a surprise is some of the other findings, like the snapshot and the wrist shot outside the target zone.
Yeah.
I wouldn't have guessed that.
Yeah.
The wraparound is a very low probability. Yeah, that's
Yeah. Even if they don't do anything, they can just stand in front of the net, which is basically, as well, with a name that you folks might be more familiar, basically how Ryan Smith made his career. So that's yeah. Yeah.
It's actually goals, big. It's goals.
Yeah. Hey, they all count the same, and he's all taken them within the home plate area. I don't think that guy took a shot from outside there since '93. So.
Okay, no more questions?
All
Awesome.
right.
Thanks
All right.
so much, Dan.
Thanks, folks.
So I always like to start my talks by saying that I actually make these presentations with a very specific beginner intermediate Python user in mind, me, in case you're still wondering. So hopefully, like me, if you are like at the beginner intermediate level, this would give you a cue as to the power of decorators. And if you're experienced with Python and decorators, hopefully this would be like a good primer to just refresh your mind as you go along. So if like me, when you really got deep into Python and you saw like weird signs like art as if you're tweeting at someone and you're like, what's this about? Hopefully by the end of today, you know what this is about. These art symbols in Python are called decorators, and there are so many examples of decorators being used in both the standard library and then also third-party modules that you find on PyPI. So this is, I think this snippet is from the official Flask tutorial. Anyone that writes applications in Flask would immediately recognize this. So decorators, I think, are such an important aspect of Python programming. I actually found 2 enhancement proposals related to decorators. PEP 318 from 2003 and 3129 from 2007. So decorators have kind of been part of core Python going all the way back. And I think this would be a good opportunity to just refresh our memories on what decorators are and how we can use decorators. But first, what are decorators? Sounds pretty obvious. Decorators decorate functions, or more specifically, not just functions, any type of callable. So a callable in Python is an object that implements the done.call protocol. Or in simple terms, if you can put parentheses around an object and actually make it do something, then it's a callable. Typical example of callables will be like functions or methods that you define within functions and all whatnot. So With the decorator, you put like a wrapper around the function or callable, and you make it do something really fancy beyond what the original callable should do. Why would you ever want to use decorators? So say you have a use case where you've written a function or a callable, you have it do something, but sometimes you actually want to modify the behavior of that callable. You want it to do something slightly differently, but you actually don't want to change the callable entirely. So, of course, one naive approach would be, if I want my function to do something, I'll just go and rewrite. Well, with decorators, you can actually modify the behavior without permanently changing that callable. Typical use cases that I found for decorators would be things like logging or timing. So if you use Jupyter Notebooks or IPython, there's a % time it magic that you can use to time how long it takes for a block of code to execute. So under the hood, that's just a decorator. You can also use decorators for things like caching. So if you want to run an operation or a block of code once and store the results, and next time you try to call that same block of code with the same input, instead of having to run the code all over again, you just want to get that result, then decorators are also actually a good use case for that. But there are a few things, if you're just new to decorators, a few things about Python and Python objects that would help you grok what decorators do. First thing, in Python, everything is an object. Literally, everything that you do in Python is an object. And Python functions are first class. So one implication of everything in Python being an object is that variables that you define, so when you say you're writing a line of code and you say x equal to 5, that x variable and 5 are two separate entities. So in memory, there's an int object that has the value 5. And then there's a variable x that points to that int object. And you can actually have multiple variables pointing to that same object. And the way to know that you have two variables pointing the same object, if you say B is C and you get true, then you know it's basically pointing to the same object. So I just found this neat little meme on the internet. With some other languages, if you have two variables, say A and B, and you're trying to swap the values, in Java or C++, you have to do a lot of gymnastics to actually reassign those values. But in Python, you just do A, B equals to B, A. Because what you basically do is you have A pointing to something and B pointing to something else, and you just change the pointers and voila. No gymnastics. So I just wanted to emphasize a bit what it means for functions to be first class. It means that you can assign functions to variables, you can pass a function to a variable, and you can also return a function from another function. And you can also define functions within functions. And when you define functions within functions, the inner function actually has access to the parameters that you pass to the enclosing function. And there are a few actually practical examples of this. So here I'm defining the function called print greet, and surprisingly I'm just returning hello world. And then I assign that function to a variable called sayIt. And then when I call that variable sayIt, I get the result of calling the function directly. Also, I can define a function within the function and have that other function return my other function, if that makes sense. So here I'm defining one function called isCalled, and then an inner function called isReturned. And within the outer function, I'm just returning the inner function. And when I actually call that object, again, I get the behavior that I expect. And then also you can pass functions to other functions as well. So here I'm just basically defining the function, but at the point where I'm defining the function, I'm just saying, I'll give you an input called func. And what func is, I don't know at that time. I'm saying when I give you an object called func, call that object with, I hope this is not too difficult to grok. And then I can separately go and define that function that I'm passing to the other function. In this case, I'm saying is question. And what I basically do here is whatever text that you get as input, add a question mark at the end. And again, if I call that, if I pass is question to mind blowing, I get the result that I expect. So generally in Python, functions that accept other functions that as input or output are called like higher order functions. Example of this would be like map, filter, reduce. I know back in the days, being able to use map, filter, reduce in your Python code was proof that you were among the super elites class of Python programmers. But my experience is recently, there are easier ways to achieve most of the things that you can do with like map, filter, and reduce. And in most cases, you should probably go with like comprehensions and make it easy for everyone to understand. So back to decorators. So we'll start with a really simple example, what I call a null decorator. So it doesn't really do anything. I just pass it one function and return the function immediately. And now I actually define a separate function called greet, and I return that string hello Py Edmonton. And then when I want to get the behavior that I want, I pass my greet to my null decorator, and actually get it to do what I want it to do. This doesn't really look particularly useful at this point, but I promise as we go along, you actually get, I'll try to tie it all together. We can also add some syntactic sugar to how we use the decorators with our functions. And again, that's the add syntax that you saw earlier. So now instead of saying I'm passing greet to my null decorator, I just put when I define the greet function, I put the decorator on top. And that would be the use case that you see in most cases. You just see an add syntax at the top and then a function defined. Once you see that, you know that this is the decorator that I'm applying to the function I'm about to define. Now for a more useful example of decorators, I'm defining what I call an uppercase decorator. And what I basically tell it to do is if I pass an object to you, call that object and then turn the result to uppercase. And then I use that to, again, decorate my confirm understanding function. And when I print, even though confirm understanding should be lowercase, because I've decorated with the uppercase decorator, then it actually turns it to uppercase. So again, explanation, the wrapper closure has access to the input from the undecorated function. And using the wrapper, you could say, do something before you call the function that you actually execute and then do something afterwards. This is important because with decorators, you actually, maybe when you're doing login, you want to do something, print something to the user screen, call the function, and maybe take the results of the function and save it somewhere, save it to a log file or whatever. Again, what was I trying to demonstrate here? So yes, I wanted to show that you can actually use a decorator to do something before you call the function that has been decorated and then do something afterwards. So here what I'm basically doing is I just print a line of text telling you I'm about to decorate this function. Then I call the function and do what I want to do within the function, and then I can do something else afterwards, which I basically demonstrate. So before I call, I tell you I'm about to decorate, I decorate, and I'm done doing this. And when I actually call the object, I can see all of the behavior that I expect to embed within. So, so far so good. We know decorators can modify the behavior of callable using the wrapper closure. Decorators are, what's the right word I'm looking for? The importance of decorators lies in the fact that you can actually modify the behavior of the callable without permanently changing that callable itself. So say in Dan Bader's Python tricks book, he actually describes a scenario where you're a programmer, it's 4 o'clock on a Friday evening, and your manager just approaches you and say, oh, that's code that we wrote for a client and shipped 2 weeks ago. They actually want like a login function for us to actually save the output of the program to a log file. And if you really don't know about decorators, you might spend the next 2 hours hitting your head against the table. Or if you know decorators, you could write a quick decorator and use that to decorate all of the functions that you have within your code and be done in a couple of hours. And again, to emphasize, the behavior of the callable that you modify with the decorator is only modified when you apply the decorator to it. You still have access to the unmodified function. For example, here, doing the same thing I did earlier, I have a decorator called explicit title case, and then I define a function called confirm understanding. I can call confirm understanding, I get the normal behavior. It's still undecorated. But I can also decorate. I can also decorate that and actually get the kind of behavior that I expect. Okay. So you might ask, if decorators are so useful, what if I want to do multiple things at the same time? So yes, you can also apply multiple decorators to a function. The way to do that is, in this case, I'm defining, like, as you might have a use case where I have a text that the user is sending in, and I actually want to wrap that text around HTML, some HTML tags, and get HTML output. So I'm defining a div tag and a paragraph tag, HTML tags. And what I do is I have a function, and I apply these two decorators. And this is what the output would look like. So first, it will do the paragraph, and then it will do the div. And that is because when you call multiple decorators, it's like a stack that starts from the bottom. So you call the paragraph first, and then we'll call the div, not from top down, as maybe you might be mistaken to assume. And I can do this with more than 3 decorators as well, so you can stack multiple decorators on top. So in this case, what I'm doing is, first I wrap it in a paragraph, and then a div and a paragraph. And if I wanted, I could keep stacking divs and paragraphs and divs and paragraphs until I get confused or the whole thing falls on top of me. And this is what you see here. One thing to know is when you stack too many decorators, then it can actually start to affect the performance of the callable that you have buried under that pile. Especially if you're doing a lot of processing with those decorators. So just something to keep in mind. Try not to nest your decorators too deeply. Okay, and if you notice, all of the examples that I've been showing prior to now are actually functions that do not accept arguments, which is, in most cases, you want functions that accept arguments. So if you wanted to decorate a function that accept arguments, star args and star quags are your best friend. And what you basically do with this is you can pack all the positional and keyword arguments and then pass it within, which I'm basically demonstrating here. I have a decorator called proxy, and I pass it a function. And within the wrapper, I'm collecting all the positional and keyword arguments that func should take, and I'm calling func with those arguments, and then I'm returning the wrapper. So basically, like I said earlier, the star and the star args will collect all the positional arguments, and star quags would collect all the keyword arguments. So keyword argument would be like if you say, with y calling the function x equal to 5. A positional argument will be you're just calling the function and saying 3, say I have a function that adds 2 numbers. If I say 3, add 2, 3, 5, then 3 and 5 will be like positional arguments. But if I say add 2, x equal to 3 and y equals to 5, then that would be a keyword argument. Okay, now time for a practical example. All I've been doing prior to now, pretty much useless functions that either don't accept arguments or are not really useful. Hopefully this would help to tie it all together. So here I'm doing a trace decorator, and what I basically want to achieve with a trace is explicitly tell me when I'm calling a function, what I'm about to, the arguments that I'm passing to the function, and then when you're done, show me the result of calling that function explicitly. So on line, even though we can't see line numbers, on line 3, I'm saying print, call the trace and say I'm calling this function with these arguments. And then when you're done, tell me what the function returned. And if I apply that trace to some useless function that I wrote, whodunit, and I'm saying when I call whodunit, tell me the name, the thing, the venue, and how it feels. And what I'm saying in this case, whodunit, who is I, what did I do? I presented on decorators. Where did I do that? At Pi Edmonton. How did it feel? It felt great. My trace tells me I'm calling this function. These are the positional arguments. So the positional arguments will be collected inside of the parentheses, and the keyword arguments will be collected as a dictionary. So you could see it's telling me venue. The value of venue was Pi Edmonton. How it felt is it felt great. And then the positional ones are I and whatever I put before there. And then it calls the function, and afterward it tells me what the result of calling that function is, in addition to actually doing what the function was supposed to do. So in this case, when I defined the function, I said return this. So the trace is done, and then the return value of calling the function is actually ejected, which actually prints I presented on Decorators to the screen. So that's basically the most important part of Decorators. So Decorators modify behavior of callables, can do that without permanently changing the callable itself. But there's a problem. When you decorate a function, you lose access to some of the metadata of the callable or the function that you initially defined. So I'm going to demonstrate that. So if this function that I defined earlier, whodunit, that I decorate with trace, if I try to, okay. So first, the function is whodunit, and this is what it does. And then I can inspect the name, introspect the name of the function and the doc string. So when I introspect the name, it tells me this is the name of the function. When I check the doc string, it actually prints out the doc string that I had from here. But if I decorate that function and I try to do that introspection, I don't get what I expect to do. So if I try to say, function, what is your name? It says wrapper. And what's the doc string? None. So I've lost access to all of that metadata associated with the function, and we really don't want this. So do not despair, there's a way, and that way is another decorator from the functools, from the functools module. And I found this to be really meta. The way to actually get your decorators to be debuggable is to use another decorator. So basically, anytime you write functions that you decorate, use the wraps from functools. Once you apply at wraps, then you still get access to all of the metadata from the function. As I demonstrate here, I can still do introspection with this and say, what is your name? And I get what I expect, and I can say, what's the doc string? And I get the doc string associated with that function. And that's pretty much it. Hopefully, you've learned about decorators. Really neat tool to have in your toolbox, especially if you are just getting started in your Python journey. I know this was a quick primer. Probably didn't teach you all that you needed to know, but hopefully got you excited enough to go back and dig into all of the details about decorators and all the awesome things that you could do with decorators in Python. Just emphasizing some of the things that I said earlier, you can modify a callable without permanently changing the callable itself. There are extensive use cases of decorators in the standard library and third-party modules. Some of the most third-party modules that you would use a lot if you do like front-end development with flags. When you say at app.route, that's basically a decorator. And I can't remember if we have lots of decorators in Django as well, but I'd like to think so. And then there's an ongoing proposal to change or to relax some of the restrictions of the grammar syntax with decorators in PEP 614, proposed by Guido himself sometime this year. And so hopefully when that proposal passes, decorators in Python will be a lot more powerful than they are right now. And that is my talk. These are some of the resources that I relied on while presenting Dan Bada's Python tricks. There's an article on program viz on decorators. Awesome Python decorators just give you a listicle of Python decorators in the wild, both from the standard library and third-party modules. And then there's a real Python article on decorators that goes into a lot more detail that you can refer to. And my slides will be posted on GitHub at this link, and I will put the link on the Pi Edmonton Slack channel as well. Thank you for listening, and hope I didn't bore you too much. Yes.
If we're going to have an inner function, exactly named wrapper.
You can call it whatever.
No, I mean, if we're going to have an inner function, or we can just escape the function and do something. For example, in your starting example, you don't have an inner function.
Yes, I don't. But I think if you actually need to do something before calling the inner function and afterwards, then you should use an inner wrapper.
And my other question is, it's possible to actually have some parameters for the decorator itself. For example, trace that function with the variables.
Is it possible? Yeah. Okay. That's not a use case that I've seen, but probably is. Yeah.
Use cases typically on like a lot of decorators are used when you're testing, and you can like skip a test and pass some variables.
Yeah. All of those PyTest fixtures and PyText.
To pass parameters into a thing, you do that with patch. So if you're trying to like kind of like mock out in testing, that's done quite a bit with patch.
There was 2 examples in your own presentation about wrapping functions that take arguments. Both the wraps function takes an argument and the class app takes an argument.
Okay. Thanks for that. Any more questions? None? All right. Thank you. Thanks everyone for coming.